Algebra 2, set 94, dependent and independent variables, functions, and functional notation. Okay, so if you have an equation, y equals 2x plus 4, and you can let x equal 5, you can solve that equation to find y equals 14. You could just as easily say let y equal 14 and then solve for x. So subtract 4 and divide by 2, you get x equals 5. But most of the time when we're solving equations, we are dealing with letting x be a certain variable and then solving for y. It's just the standard way of solving problems. So when we talk about independent variables versus dependent variables, independent variables are the ones that are assigned the value. So in our first equation, our independent variable is x. In our second equation, the independent variable is y. The dependent variable depends on the independent variable. So again, our first one, x was independent, so 14, the answer 14 depended on x being 5. And then the second one, same thing, when we had y was equal to 14, x depended on what y was. So the dependent variable depends on the independent variable. In most cases, as I said, x is the independent variable and y is the dependent variable. When you make a table, your independent variable always comes first. So for example, if you have this particular situation, y equals 2x minus 3, y depends on what x is. If you have a graph, the x is always the independent variable, it always goes on the bottom, and y is the independent or dependent variable. Okay, so now if we have both of these cases and we let x equal negative 3 and we solve, 2 times negative 3 plus 4 is negative 2, and then negative 3 cubed is negative 27 minus 12 plus 3, so we end up having y is equal to negative 36. In each of these cases, we're given an x, and we got one answer when we solved it. When we plugged x in, we got one solution that came out. So for any given x, there's one and only one answer. This is an example of an equation that will give you more than one answer. Let's say that x equals 4. So y squared equals 4. When we solve for y is either going to be positive 2 or negative 2. So when we have an input of 4, we get an output of 2 and negative 2. So in this case, it's not what we consider a function because there are more than one answer. It doesn't have only one answer. So again, that is what we call a function. So a function can also be defined as any situation where each member of a set of given numbers or letters has only one answer. So when we put in A, we get 7. When we put in B, we get D. When we put in 4, we get 13. There's one and only one output for every input. So our input and our output can have different labels. So you can have the given being your independent variable and the answer being your dependent. A lot of times we refer to it as x and y. The x's are always the domain and the y's are always the range. Okay, a function is a set of ordered pairs in which no two pairs have the same first element and different second elements, kind of like exactly what we've been saying. Every value of x has exactly one answer. So in order to be called a function, the domain has to be specified or implied. A way has to be designated to find every image or answer. And finally, there's exactly one answer for every member of the domain. So we'll look at this problem. Which of the following depict functions? So when we're looking at these problems, we'll start with part A. We have an input of 4, it gives us 3. And then we have an input of 3, and it also gives us 3. So yes, that is a function, because for every input we get 1 and only 1 output. Even though the output is the same, it doesn't matter. Okay, for the second one, we input 7, we get 3. We input 5, we get 4. But we also get 3. So in this case, no, it is not a function because there are 2 outputs when I input 5. Okay, for the third one, I input 4, I get 5. I input 6 and I get 7. I input m and nothing happens. Because nothing happens when you put m in, you don't have an image, you don't have an answer, it is not a function. And then finally we'll look at that set of real numbers is your input, and your method of obtaining an answer is y equals x plus 2. So you can take any real number, plug it in for x, and you will get a solution, and it will be a unique solution. So yes, this is a function. Okay, which of the following sets of ordered pairs of x and y are functions? So really, when you're doing a problem like this, you only have to look at the x's to begin with. So I look at 4, 7, -3, and -6. Since all of the x's are different, I don't have to worry about anything, so yes, it is a function. If we look at B, 4, 5, 7, and 6. They're all different, they all have answers, so yes, it is a function. Part C, 5, 4, 7, and 5. Now, I notice I have 5 that is repeating. So, in one case I have 5, -2, in another case I have 5, 4. So, in this case, I have an input that gives me 2 different outputs, so no, it is not a function. And then the last case, 7, 3, 6, 4, there's no repeating, so yes, it is a function. You'll notice that in the sets of ordered pairs that say yes, there are repeats. Like if you look at B, it has 4, 3, 7, 3, and 6, 3. The fact that the y's are all repeating does not make a difference. It's just x's that are repeating that we're worried about. Okay, so if you have 2 equations, one says y equals x plus 2 and another says y equals x minus 5, sometimes it's hard when you have more than one equation to figure out what equation that the problem is asking about. And so we have what is called function notation. So functional notation is basically just taking those same equations and putting them in a different form so that they have a different label. So we take the first equation and we call it f of x, and we take the second equation and we call it g of x. So in this case, we have an f of x and we have a g of x, and now they have their own specific labels. So if I'm asked to find g of 2, I take 2 and I plug it in for x, and so I get g of 2 equals 2 minus 5. So g of 2 is equal to -3. And you say it, g of 2 equals -3. Okay, if h of x equals 4x minus 3 and p of x equals x squared minus 3x, find p of -3. So we don't need the h of x function at all because we're just dealing with p. So p of -3, we're going to take it and plug it in for x, is -3 squared minus 3 times -3. So again, I'm using just that p of x equation because I'm dealing with the p in front. So -3 squared becomes 9, and -3 times -3 is also 9. So my solution for p of -3 is 18.